There are two methods to evaluate a definite integral using substitution. Let's do both in this video. So the integral we have is the integral from 0 to 1 cosine of pi t divided by 2 dt. So first of all, the first method is I would like to change the upper and lower limit. So since this is a dt, right? The 1 is t equals to 1, the 0 is t equals to 0. Let's do the u substitution first. We let u equals to pi t divided by 2, and then du is going to equal to, so the constant is pi over 2, right? So you have a pi over 2 dt, and then you isolate the dt on both, on the right side, you have 2 divided by pi, and then du equals to dt. So normally we will just substitute the 2 over pi du to the dt, right? So normally we just do this substitution. So let's get the arrows right. We just substitute like that. But since this is a definite integral, we have to change another step, because this problem is supposed to be, let me erase the 0 and the 1. This is t equals to 1 and t equals to 0. We are going to change the variable from t to u. So the t equals to 1 and the t equals to 0 needs to go away. But how do you change the 0 and 1 in terms of u? So here is how. So this is new. Let me do this in another color. So what you have to do is you have to do a u of 1. So u of 1 means you have to replace the t with 1. So that will be pi times 1 divided by 2, that is equals to pi over 2, and then u of 0, that is pi times 0 divided by 2, that is equals to 0. So when you write your integral, here is how you write it. So you write an integral. So now I do u equals to pi over 2 and u equals to 0. And then the cosine becomes a cosine of u, and then you have a 2 over pi du. So now everything is in terms of u. Since the 2 over pi is a constant, you can just ignore that. So basically you are trying to integrate the cosine. So the cosine, the integration of that is equals to sine. So we have a 2 over pi. The integral of cosine is equals to sine of u, and then u goes from 0 to pi over 2. Oh, let me remind you one thing. Sometimes after you do this process, the upper limit may be less than the lower limit. Again, when you do this process, the one right here, after you completed this process, the upper limit sometimes, not always, sometimes, the upper limit is less than the lower limit. Don't worry about it. Just plug in what you got from that step. All right? So let's go back to the problem. So we have a 2 over pi sine of pi over 2 minus 2 over pi sine of 0. So sine of pi over 2 is equals to 1, right? So we have 2 over pi sine of pi over 2, y is equals to 1, and then sine of 0 is equals to 0. So overall, we only have 2 over pi for the final answer. Right? So in the next method, I will show you how to evaluate this definite integral using substitution without changing the 1 and 0. So let's do that. So first of all, we still let u equals to pi t over 2, and then du is equal to pi over 2 dt, and then we have 2 over pi du equals to dt. All right? And then the next step is you just perform the u substitution. So you do this, the integral. Don't write the upper and lower limit. You have cosine of u, and then times 2 over pi du. That's it. What I did is I replaced the dt with this piece. Right here. I replaced the dt with that piece. And then what about the upper limit and lower limit? You don't write the upper limit and lower limit. If you do this, look, if you do this 1 and 0, this is wrong. Look at the 1 and 0. If you have the 1 and 0 right there, that is not appropriate, because that is t equals to 1 and t equals to 0. The variable is u, it's not t. You cannot have t in the upper and lower limit. So that is wrong. So the correct way to do it is do not write the 1 and do not write the 0. So we integrate first. Okay, so let's integrate. So that is a 2 over pi, right? The integral of cosine u is sine of u. So that is what you do, right? Sine of u. Looks like you add c to it, but we do not plus c right now because this is a definite integral. And then the next step is you have to plug in the t back to the u. So you have a sine of u right there, right? So you have to plug in a t. So you have to plug in the pi t over 2 back here. So what that gives you is, that gives you a 2 over pi, and then we have sine of pi t divided by 2. So now we just went from u back to a t. So this is in t now. And then you can write such that t goes from 0 to 1. And then you plug in. So you have a 2 over pi, and then sine of plug in a 1, then you have a pi over 2, plug in a 0, you have a 0. So sine of 0 is 0, sine of pi over 2, so sine of pi over 2 is equals to 1, then you have 2 over pi times 1 minus 2 over pi times 0, then you have a 2 over pi. So two methods gives you the same answer. Which method do I use? I use the one on the left, because if you open up any textbook, they will introduce the one on the left. But if you prefer to use the one on the right, that method exists, but I don't use that very often. I already get used to the method on the left. But when you show the method on the left, you have to show what I wrote in the green rectangle. You must show that procedure, show all your work, right? But if you do your works online, they are only looking for the final answer. That is another problem. But if you're doing this on an written exam, you must show everything I wrote in the green rectangle. All right, so that is the end of this video. If you think my instruction is helpful, let me know in the comment below. Like the video, subscribe to my channel, share the video for me. Appreciate your help. See you all in the next lesson. Signing off for now.